Hello students, welcome to the lecture series of methods of differentiation, and this is our lecture number 6, and in this class we are going to discuss about logarithmic differentiation, and this is part 1. This is the class 1. Actually we are going to take 2 classes of this chapter, and in this chapter there are 2 categories of problems. So in part 1 I am taking one of the category, and in the next video, in the part 2 video, I will take the rest of the problems of the chapter logarithmic differentiation. Logarithmic differentiation, it is actually means that differentiation with the help of logarithm, that is called logarithmic differentiation. So here you see, when we have to use the differentiation with the help of logarithm. So logarithmic differentiation. First of all, we have to know in which problems we are to use logarithm. That is the main thing. You should know in these problems you are to use logarithm, or in these problems you should not to use logarithm. That is the main thing actually for this chapter. So in which cases we are to take logarithm, I am going to write that. Here simply, if the given function is of the form some fx to the power gx, fx and gx both are functions, in generally base and power both should be functions of x or functions of y, then we are to use logarithm. So first I am writing that one. You see here, when the given functions contains the product or quotient of several functions, or in the base and indices there are variables, then we take logarithm before differentiation. That is the main thing actually, when to use logarithm in the process of differentiation. That is the main thing. So in what cases? When the given function, you see here, when the given function contains the product or quotient of several functions. Product mean it may be product of say 10 or 20 functions, x minus 3 into sin x into cos x square into log of x plus 1, and so many functions, product of so many functions, or quotient. Quotient mean in the numerator there are some functions, in the denominator there are also some functions of x. It may have whole to the power something. If these types of functions you have obtained, then you should use logarithm before differentiation. But in these two cases, that is product of so many functions or quotient of so many functions, in these two cases it is not mandatory, it is not compulsory to take logarithm before differentiation. That means I am trying to say you that in these problems where the function is a product of so many functions, or the function is a quotient of so many functions, we can solve those problems without the help of logarithm also. But to get easy calculations, we use logarithm before differentiation in these cases where the function is given in the product form of so many functions, or it may be in quotient form of so many functions, or it may have some powers, constant powers also. But the important thing is, if the function is of this format, fx to the power gx, or fx to the power gy, or gy to the power fx, mean in base and in power both have variables. Base and power both have variables, then we are to use logarithm before differentiation, and this is compulsory. You recall the formula of differentiation. You will see there you have a formula for x to the power n, where n is a constant number. You get my point? You have a formula for differentiation of x to the power n, where n is a constant but x is variable. You have also a formula for differentiation if y is equal to some a to the power x, where a is a constant, x is variable. No doubt this x may also be other expressions, this x may be other expressions, but we have this formula, that is variable to the power constant or constant to the power variable, we have formula. But variable to the power variable, we have no formula for differentiation, and that is why if those types of functions are obtained to differentiate, then you should use logarithm before differentiation. That is the main topic. I am erasing this. So this is for Assamese medium students. You may write the notes here. Actually, they demand to write the notes in Assamese. So I will try to write the notes in Assamese also in after this class. Okay, you see this one. Oh, here it is fx to the power gx, gx to the power fy, fy to the power gx, anything. That means variable in the base, variable in the power also. It is not only fx to the power gx, it may be y, it may be x, it may be x, it may be y, both may be y. Okay. So in these cases we should use the logarithm before differentiation. So let me go to the problem section of the chapter. So find dy dx, y is equal to, this is given. You see, this problem can be solved by using direct differentiation, because if you complete the product in the numerator, then it is root over of some expression of x and divided by this term. Then if you use direct method, dy dx is equal to, first you are to write the derivative of root over function, mean 1 by 2 root over, this total term will remain same, into ddx of this inner part. So in that part, denominator is square, denominator into derivative numerator minus numerator into derivative denominator. That is the straightforward process. But in this chapter, I am going to use logarithm to solve this problem. Okay, so taking logarithm with the base e. Actually, if you take logarithm, then obviously it will represent the base is obviously e. You may not write in your exam, but if you write this, it is better than the best. Actually, if you write with the base e, it is better than the best. But if you do not write this, automatically it will indicate that the base of the logarithms logarithms are e. So log y is equal to log of root over this one. I am not writing the base here, so obviously the base will be e. So log y is equal to this one, and root over mean these terms whole to the power half only. Okay, so log y is equal to, that half will come in front of the function by the property of logarithm. So log of these terms are remaining same. Now apply again property of logarithm. We know the property of logarithm, that log of fx into gx, then log fx plus log gx, log of fx divided by gx, then log of fx minus log of gx. Mean if it is in product format inside logarithm, then we can distribute the logarithm by taking plus between the functions, or if it is in divide form, then you are to write minus to distribute the expressions. So I am using that property only. So log y is equal to half. This is log of x minus 3. This is product, so plus log of x square plus 4, and this term is this term is in the denominator, so minus log of this one. So now differentiating with respect to x. You are to write this line because the function is in implicit form. What is the cause? Because y is inside log, so it is in implicit form. So differentiating with respect to x. So log y differentiation is 1 by y, and for y differentiation is dy dx is equal to half constant remaining same. Log x minus 3 differentiation is 1 by x minus 3, you know the formula, into ddx of x minus 3 is simply 1. X is 1 and 3 is 0, so it is simply 1, and that is why I am not writing here. Then plus this log differentiation is 1 by x square plus 4 into differentiation of x square plus 4 by chain rule, that is simply 2x, then minus log function differentiation is 1 by 3x square plus 4x plus 5 into differentiation by chain rule of this one, it will be 6x plus 4 only. Okay, So dy dx will be equal to, just y will go on the right hand side by taking cross product. So dy dx is equal to half into y whole into this terms are remaining same, 1 by x minus 3, 2x by this one, and this is 6x plus 4 by 3x square plus 4x plus 5. Then just apply the value of y here. Y is this part. Okay. So this is equal to half of, this is y, this is y giving here, and these are the terms. These are the terms, and that is the solution for the question. Very simple. This is the next question, and it is homework for you, and simple. Use the previous method also, and you may use the general method. But in this chapter, since the chapter is logarithmic differentiation, you are to use logarithm. So this problem you can solve with the help of previous problem. And then the third question, y is equal to this one. It is cube root. Okay. So here complicated. This time if you differentiate it directly, it will be critical, because denominator is root over, this is cube root over, so it is very hard. Okay. So this is the question now, and here you take logarithm. So taking logarithm with the base e, so left hand side is log y is equal to, this is product, I am writing skipping one line, directly writing here. So log of x into, so log of x, this into will be plus, then it is whole to the power 1 by 3, so that 1 by 3 will come out into log of x square plus 4, and this is denominator, so minus, this is denominator mean quotient, so minus, square root mean that power half will come out of the logarithm into log of this x square plus 3. Now take differentiation. So differentiating with respect to x, it will be log y, so log differentiation is 1 by y, and for y you are to write dy dx is equal to this log x differentiation 1 by x plus 1 by 3 is remaining same, log differentiation is 1 by x square plus 4 into x square plus 4 differentiation is 2x only, then minus half, then again logarithm differentiation 1 by x square plus 3, and this x square plus 3 differentiation is only 2x. This y, this take this y on the right hand side as cross product. So dy dx is equal to y whole into this 1 by x, this is 2x by 3 into x square plus 4, minus this is 2 cancel, here 2 is cancel, so x by x square plus 3. Just replace the value of y by this one. Okay, so dy dx is equal to, this is the value of y, and the rest of the terms are as it is. So that is the solution of the problem. So this is the new question, y is equal to cos x into cos 2x into cos 3x. No doubt this problem you can solve without the help of logarithm. U into v into w. I told in the first year classes that if you have three functions like this, you see here, if you have three functions, y is equal to u into v into w. U, v, w all are functions of x, then dy dx is equal to, sorry, not dy dx, oh yes, then dy dx is equal to, first derivative of u, it is du dx, then vw remaining same, plus then u remaining same, v differentiation is dv dx, and then w is remaining same, then plus again uv remaining same, then dw dx. So this is the process of differentiation if the function is given in more than two functions, product of more than two functions. It may be 4 also, u, v, w, say r, then first time differentiation of u, rest of the terms remaining same, then second one differentiation, rest of the terms remaining same, then third function, then fourth function. This is the way of differentiating if the given function is a product of some functions, more than two functions. But if we use this process, it is somewhere lengthy. Okay, so in this case also we take logarithm before differentiation. No doubt you can solve this same problem with the help of this process. Okay, so now taking logarithm here again, just a second, okay. Okay, so taking logarithm here, log y is equal to, this product will be converted to plus, so log of cos x plus log of cos 2x plus log of cos 3x. It is easy, calculation is easy, this method. So differentiating with respect to x, the line is compulsory because y is inside the logarithm function, means this function is an implicit function now. So differentiating with respect to x is equal to this log y differentiation 1 by y for y dy dx is equal to log cos x differentiation 1 by cos x, then cos x differentiation is minus sin x by chain rule, it is by chain rule, then plus 1 by cos 2x for this one, 1 by cos 2x into cos twice x differentiation is 2 sin twice x and cos is negative, it is mx type, cos mx, so 2 sin twice x, and since cos it is negative, then plus this log is 1 by cos 3x into this cos 3x differentiation is minus 3 sin thrice x. This is m actually. Formula for cos mx is equal to minus m sin mx, that is the formula. It is obtained in the first year classes. Okay, so then just simplify it. So dy dx is equal to, this y is going to the right hand side as cross product. So y whole into, this is minus 10x minus, this minus is coming here, 2 into, this is 10 twice x, then this minus is coming here, 3 into, this is sin 3x by cos 3x is 10 3x, then replace the value of y only, this is the value. So is equal to, minus is taking outside of the bracket, so minus cos x, cos 2x, cos 3x is the value of y, and these terms are 10x plus 2 10 twice x plus 3 10 thrice x is there, and that is the solution for the problem. And this question is homework for you. Y is equal to x plus 3 whole square into x plus 4 whole square into x plus 5 whole to the power 4. This is whole cube, not square, whole to the power 4. Then if you take logarithm, this product will be plus and these powers will come out of the logarithm. So after that you take the differentiation and you will get the answer as the previous problems. So this is the question, y is equal to x to the power x is important question. So many times we are to take logarithm x to the power x in the future. So y is equal to x to the power x. This time you see base and power both are variables. X to the power x both are variables. A to the power x has the formula, x to the power n has the formula, but x to the power x we have no formula about this. So in this case we must take logarithm before differentiation. This problem cannot be differentiated without the help of logarithm. Okay, but in the previous 3-4 problems you may use logarithm or you may not use logarithm. Okay, but in these types of problem where base and power both are variables, you have to take logarithm in always. So log of y, it is, I am writing ln here. Ln means actually base of logarithm is e only, nothing else. So log y is equal to log of x to the power x. Very simple. Then use the property of logarithm. This x will come in front of the logarithm. So log y is equal to x log x. X log x. Now take differentiation. So differentiating with respect to x, you are to write this line because y is inside logarithm. That means it is an implicit function. So you are to write this line. So the differentiation of log y is 1 by y, and for y you are to write dy dx is equal to, this is a product function, log x into log x. So x into log x, product function, differentiation of x is 1, log x remaining same, plus this time x is remaining same, and differentiation of log x is simply 1 by x. So this x will cancel and y will go to the right hand side as cross product. So dy dx is equal to y into log x plus this x is cancelled, 1 is remaining there, and finally you replace the value of y here, x to the power x. So dy dx is equal to x to the power x into, it is 1 plus log y, 1 plus log x. So that is the solution for the question. Now you see this same problem can also be done by another method. We have an alternative method for these types of problems where base and the powers are variables. So you may use that method also. You see this method, alternative method. So y is equal to x to the power x. Then here we are taking logarithm in manual basis, line by line, but here I am taking logarithm but in some special, using some special property of logarithm. You see, we have a property for logarithm that, you see here, we have a property that a to the power log of x base a is equal to what? It is simply x. That means this base, exponent base, and this logarithmic base, if these two bases are equal, then we have to write x only. This value is only x. That means base and the logarithmic base both are same, then it is simply x. So using this property here, you see, I am writing the right hand side in some modification here. This x to the power x is already here. Just I am taking these terms by writing e to the power log of x to the power x. This term is remaining same. You just write the terms in powers of e. E to the power log, the terms are remaining same. E to the power log, the terms are remaining same. When the base and the powers are variables, then you are to write that term where base and powers are variables, that term in a format of e to the power log and the terms remaining same. So e to the power log, this is remaining same. I am not writing here the base of logarithm. So obviously the base is e. So it is of the format e to the power log of x power x base e. That means log base and exponent base, these are same. So you can remove this one. So it will be only x to the power x, that is this. So obviously x to the power x will be equal to e to the power log of x to the power x. So it is very simple to memorize that the terms where base and power both are variables, you are to write that term in the powers of e by taking logarithm as like this, e to the power log of the term remaining same. Okay, so then you apply the property of logarithm. This x will come in front of log like this. Y is equal to e to the power x log x. Now we have formula e to the power something. We have a formula for e to the power x is equal to e to the power x. So you should consider this total term as x. So dy dx is equal to e to the power x derivative is e to the power x itself, you know that, into, now by chain rule, the power function derivative, this power x into log x derivative is 1, so log x is remaining same, plus x is remaining same, log x derivative is 1 by x only. Okay, so this x is cancelled, but you see interesting point here, e to the power x log x was actually what? It was actually this one, and it was actually this one, and that is nothing but x to the power x. So finally you replace this e to the power x log x, this e to the power x log x by x to the power x again. Okay, and this log x is remaining same, and this is cancelled, so 1 is there, and that is the answer. Dy dx is equal to x to the power x into log x plus 1. Very simple. So I will recommend you to use this method. This is easier than this. No doubt you may use this method also, okay, but this is interesting method. In your book this method is given. The first method is given in your book. This is not given in your book, but you may use this method also. Okay, so the next one, this is our problem. E to the power x is equal to, sorry, y to the power x is equal to x to the power y. Simply base power variable, so we must take logarithm here also. So log of y to the power x is equal to log of x to the power y. Both sides we are taking log only. So use the property of log. It is simply x log y is equal to y log x. Okay, then differentiate implicit function. So you have to write that line, differentiating with respect to x. So left hand side x derivative is 1, log y remaining same, plus this x is remaining same, log y derivative is 1 by y, and for y you are to write dy dx. Go to the right hand side, is equal to y derivative is dy dx, product function only, y derivative is dy dx into log x remaining same plus this time y remaining same, and log x derivative is simply 1 by x. So now you should collect the terms dy dx in the left hand side of the equation, and the terms without dy dx should be shifted to the right hand side. So dy dx is taking common here, this term is dy dx is taking common, so it is only x by y, and this term is going to the left hand side, so it is negative, dy dx is already taken away, it is minus log x only, is equal to, it is y by x already there, and log y will go to the right hand side like this. So that is the expression now. So take LCM here and here. So dy dx is equal to, y is LCM, it is x minus y log x, is equal to, x is LCM here, it is y minus x log y. Okay, then just take cross product, this y will go to the numerator and this term will come to the denominator. So dy dx is equal to y into this, y into this term is remaining same, divided by this x into, it will come to the denominator like this, and this is the solution for the question. So we take the next question. Sorry, yeah, these questions are homework for you. Similar problem like this, you take direct logarithm here, so left hand side will be y log x and right hand side will be x minus y log e, but you should know this log of e. What is the value of log of e? Is equal to simply 1, because I am not writing the base of e log here, so we should consider e is there, and we have a property that log of a base a, whatever be the value of a, but it should be a positive number, so a base a, that is always 1, that is log number divided log number and base. If these two numbers are same, then the value of logarithm is 1, you know that one. Okay, so on the right hand side in this problem on the right hand side, it will be x minus y into log of e, but log of e is equal to 1, so right hand side is simply x minus y, then take differentiation. In this question, log y is equal to y log x. In this question, taking log, left hand side is x log x, right hand side is y log y, process is this one. Okay, so I think you can solve all of these three questions, very simple questions, so you solve as homework. So we take next question. This is x to the power y into y to the power x is equal to 1. Again you take logarithm here, so log of x to the power y into y to the power x is equal to log of 1. The value of log 1 is 0, and use the property of logarithm, this is product, so this log will distribute among these two, having plus sign in between these two. So log of x to the power y plus log of y to the power x, and value of log 1 is 0. Then use property, this y is coming here, this x is coming here, y log x plus x log y is equal to 0. Now differentiate. So differentiating with respect to x, so first we are taking differentiation of y log x. This is product function y into log x, so dy dx, y derivative is dy dx, log x remaining same plus y remaining same, and log x derivative is simply 1 by x plus this one. Come to here. Now x derivative is 1, log y is remaining same into x is remaining same, log y derivative is 1 by y, and for y you are to write dy dx. Right hand side is already 0. Then collect dy dx, that is taking common dy dx from these two terms, and these two terms will shifted to the right hand side. So dy dx whole into, here log x is remaining and here x by y is remaining, because dy dx is already taken away of the bracket, is equal to, this is y by x and this is log of y, both are negative on the right hand side, and I am taking negative common here, So it is log y plus y by x. As like is the previous problem, take LCM here, take LCM here. So dy dx into this is LCM y, so it is y log x then plus x is equal to this minus is remaining there, LCM is x, so it is x log y plus this y, and then just take cross product, y will go to the numerator and this term will come to the denominator. So dy dx is equal to this one, and this is the answer for the question. Okay, so the next one is homework for you. Y is equal to x to the power 10 into 10 to the power x. So here you can solve this problem without taking logarithm, because x to the power 10 we have formula 10 into x to the power 9, and 10 to the power x we have formula 10 to the power x into log of 10, and this is a product function. So dy dx you can directly write dy dx is equal to 10 into x to the power 9 plus 10 into x to the power 9 into 10 to the power x remaining same plus x to the power 10 remaining same into ddx of 10 to the power x is 10 to the power x into log 10. So you can write in that way also, and you may use logarithm also. By taking log, it will be log y is equal to 10 log x into 10 log x plus x log 10, then take differentiation. Answer will be same in both cases. So this is homework for you. And this is our next question. Y is equal to 10 to the power x. So take logarithm, simple. So log of y is equal to log of 10 to the power x. Simplify here. Log y is equal to this power 10 to the power x will come in front of log. Not this x is coming here, because whole power log 10 to the power what, that will come in front of log. So it is coming as 10 to the power x, not only x. You get my point? Not only x. You should take all powers of this base. So 10 to the power x into log of 10. Do not write the value of log 10 as 1, because this base of logarithm is not 10, it is e. That is why log of 10 is not 1 in this case. Now you see again here 10 to the power x, you can take the direct differentiation also, but I am taking again logarithm. Sorry, I am taking direct logarithm because we have formula now. 10 to the power x has the formula and log 10 is obviously constant. You may take again logarithm, then it will be x log 10 into log 10, x log 10 plus log 10, then differentiate, will get the same answer. So differentiating with respect to x, it is 1 by y, and differentiation for y is dy dx is equal to, this is 10 to the power x derivative is 10 to the power x into log of 10, and this is constant remaining same, nothing else. So dy dx will be equal to y into this total terms. This log 10 into log 10 is log 10 whole square. Do not write log 10 square. Do not write like this. Do not write like this, log of 10 square, that is wrong. Okay, if you write like this, it is wrong. You should give this bracket, it is compulsory. So putting the value of y only, that is the answer. So y value is 10 to the power x here. This is remaining same and this is whole square. Okay, so very simple actually. So we take the next question. E to the power x plus y is equal to x into y. Homework. Take log. So x plus y come in front. X plus y log of e, and log e is 1. So simply left hand side is x plus y and right hand side is log x plus log y. Then take differentiation. Collect the terms dy dx in the left hand side. Take dy dx common. Then dy dx is equal to, take the division on the right hand side, will be the answer for the question. So you can solve this problem yourself. So this is our next question. Y is equal to xth root of sin x. Xth root mean sin x whole to the power 1 by x. So I am writing that line, y is equal to sin x whole to the power 1 by x. In this question you see the base is a function of x, sin x mean variable is in the base, and in the power also there is variable. So in this problem also you cannot solve or you cannot differentiate without taking the logarithm. It is compulsory to take logarithm. So log of y is equal to this 1 by x is coming here, and it is log of sine x. This power will come in front of log, so 1 by x log of sine x. Then differentiate it, differentiating with respect to x. So left hand side is log of y, derivative is 1 by y, and for y dy dx. So it is 1 by y dy dx equal to derivative of 1 by x is minus 1 by x square into log sine x is remaining same plus 1 by x is remaining same into log of sine x is 1 by sine x. Log of sine x is 1 by sine x, and for sine x it is simply cos x. This is minus 1 by x square. You got my point or not? You see here we have a formula in first year that if you have the function of the form y is equal to 1 upon x to the power n, then we can write direct differentiation dy dx of 1 by x to the power n as minus n by x to the power n plus 1. That was the formula, and here n is 1, therefore it is minus 1 by x to the power 2, that is minus 1 by x square. So you may write this formula here. You may write this formula as a side note. Just a minute. Okay, so then you take this y as cross product on the right hand side. Dy dx is equal to y whole into, this is negative log sine x by x square, then plus cos x by sine x is cot x by x. Lastly, just replace the value of y only. Y is x root of sine x. You write there. So x root of sine x divided by x square is taken common here. Divided by x square is taken common here, and so inside it will be minus log sine x plus x cot x only. So that is the solution for the question. So this is the new question. Y is equal to cos x whole to the power y is equal to sin y whole to the power x. In both sides you see base is a function of x, it is power variable is y, base is function of y, and power is variable x. So base and power in both sides there are variables, so you are to take logarithm again. So log of cos x to the power y and log of sin y to the power x. Just use the property of logarithm. This y will come in front of log, this x will come in front of log. So it is y log of cos x, and this is x log of sin y. Then differentiate it. Differentiating with respect to x, so left hand side derivative will be y derivative is dy dx, product function. So first time differentiation of y, second one is remaining same plus y remaining same, and derivative of log cos x is 1 by cos x into, for cos x derivative is minus sin x, equals on the right side it is again a product function. So x derivative is 1, log sin y remaining same, plus x is remaining same, log sin y derivative is 1 by sin y into sin y derivative is cos y into, for y derivative is dy dx. Do not forget to write this dy dx again. So then you collect the terms involving dy dx, this term and this term to be shifted to the left hand side, and the terms, other terms are on the right hand side. So dy dx is common, this log cos x remaining same, and this term coming to the left is negative, x is here, and it is cos y by sin y is simply cot y, is equal to, on the right hand side log of sin y is already there, this term is actually negative because this minus will come out, so negative going to the right hand side, so it will be positive. So y is remaining same, then sin x by cos x is simply 10x. Now just take the division here, cross product. So dy dx is equal to log of sin y plus y 10x divided by log of cos x minus x cot y, and that is the solution for the problem. So this is our question. Y is equal to x to the power x to the power x. This is the function now, x to the power x to the power 3 times. Then you are to take logarithm because base, power, all are functions of x, therefore take logarithm only. So log of y is equal to log of x power x power x. And on the right hand side you see x to the power x, this total power of x will come in front of log. It is not x log x to the power x, it should be x to the power x log x. It is log of y is equal to all powers of this x will come out, x to the power x log x. Do not write mistakenly x log x to the power x then again take x. That is a wrong way. You are to take this whole powers of this x at a time in front of logarithm. So x to the power x log x. Now you see again here the base and power are variables, so you cannot differentiate x to the power x directly. So therefore we are to take again logarithm so that this power comes as a product function. Okay, so again we are taking logarithm here. So log of log y is equal to log of this total terms. Okay, so this log of log y is equal to, this is product, so using property logarithm, so log of x to the power x, then this product is plus log of this log x is this one. Then again use property, this x is coming here, so log of log y is equal to x log x plus log of log x. Now you see there is no powers and base as variables. Now we can differentiate. So differentiating with respect to x, come to the left hand side, log of y differentiation. So first you are to take the logarithm of this log, then you are to take the logarithm of this log, then you are to take the logarithm of y dy, that will be dy dx, and this is a product function, and this is log of log x, so this log differentiation, then this log differentiation. Okay, so I am writing that one, it will be clear to you. So first log differentiation is 1 by, these whole terms are coming 1 by log y into, then log differentiation of this log is 1 by y into differentiation of y, this is simply dy dx. By chain rule only, first log differentiation is 1 by this term into, then this log differentiation 1 by this y into, then y differentiation is dy dx only, equals, this is product, so x derivative is 1, log x remaining same, plus x remaining same, log x derivative is 1 by x only, and this plus is this one, and here again taking logarithm for this log, value is 1 by log x, 1 by, for this log 1 by this log x, then derivative of log x is 1 by x only. Now simplify it only. So 1 by, this is actually y log y into dy dx. Do not write log of y square. Okay, many students write like this, log of y square, because this y is not multiplied with this log y, it is not multiplied with this y, this y is multiplying with log y, so you are to write like y log y, not log of y square, into this dy dx is same, log x is same, x cancel, it is 1, plus this is simply 1 by x log x, not log x square. Many students write in that way, so I am indicating that you do not write log of x square, you should write log of x log x. Okay, then this y log y will go to the right hand side, dy dx is equal to this y log y as cross product, these terms are remaining same, log x 1 by x log x, then put the value of log y, put the value of y is x power x, and log y is this x power x into log x. So dy dx is equal to, this is the value of y and this is the value of log y. Okay, and the right hand side log x plus 1 by x log x. So that is the solution for the question. Now you see a homework for you. This is homework. Log of y is equal to x to the power x. Simple question, you just take another logarithm on the both sides. So it will be log of y is equal to x log x. Then differentiate as like this problem. Okay, so the next question is 19 number question. Y is equal to x to the power log x to the power log of log x. I love this question actually. Very interesting question. So many logs are there, x to the power log x to the power log of log x. Interesting question, you see the problem. So first you take logarithm, so log of y is equal to log of this total term, Why I am taking logarithm? Because base is variable and power is also variable. Therefore, we are to take log in both sides. So log of this. Now use property of logarithm. On the left hand side it is remaining same, but on the right hand side you see log of x to the power, this total power will come in front of this log. Okay, so log of y is equal to this total power, log x to the power log x, log x to the power log x is coming at a time into this log x. Okay, now you see in this part it is variable and the power is again variable, so we must take logarithm again. So I am going to take logarithm again here. So log of log y in the left hand side, and on the right side taking logarithm, this plus will be split as, sorry, this product will be split as plus. So log of this term, this plus is product is plus and log of log x. So log of this term is remaining same. You see this is plus and log of this term is remaining same, just using the property of logarithm. Now in the first part here, this log of log x will come in front of this. So log of log y is same, this log x is coming here into this log x is here already, into log x is already here. Then it is actually log x into log x is log x whole square. So left hand side is same, right hand side is log of log x whole square plus log of log x. So many logarithms are there. So in the solution process you may some confusion here. So you should write in very sincere manner. Otherwise one of the log will be left out and the problem will be wrong. So you are to write in very sincere manner. Now you can take differentiation because this time there is no variables in base and powers at a time, and therefore you can take logarithm now. So differentiating with respect to x, come to the left hand side. First this log differentiation, it is 1 by log y, this is 1 by this log y. Then this logarithm differentiation is 1 by y only, into then this y derivative is dy dx by chain rule only, is equal to something whole square. So first the differentiation of whole square, that is 2 into log of log x to the power 2 minus 1 is 1 only, so 2 into log of log x into then derivative of this inner part, this inner part. So first write the derivative of first log, it will be 1 by log x, okay, this 1 by log x, into then take the derivative of this log, it is simply 1 by x. Okay, so then plus here also 1 by log x, and for log x it is 1 by x only. You take cross product, these two terms will go to the right hand side. So dy dx into, it is actually 1 by y log y is equal to right hand side. It is LCM mean I am taking common actually 1 by x log x, 1 by x log x. So it is 2 log x plus here it will be 1 because I am taking common 1 by x log x. Then this y log y will go to the right hand side. dy dx is equal to y log y divided by x log x into this term is remaining same, and that completes the solution of the problem. Next you take another question. So this is the next question, number 20, y is equal to sin x to the power cos inverse x. This is base variable and power is also variable. So this question cannot be solved without the help of logarithm. In this question actually I am going to use the alternative method of differentiation, logarithmic differentiation, the alternative mean already discussed in earlier in this video. Okay, so the alternative method is to write on the right hand side where the powers, base and powers are the variables. In that part you are to write in terms of e to the power log of the given terms. Okay, so you write that term y is equal to e to the power log of this given term, because this line and this line are actually same, because e to the power log, it is nothing actually, it is nothing. So we can write like this, then apply the property of logarithm, this will come in front of the function. So y is equal to e to the power cos inverse x into log of sin x. Then differentiate, dy dx is equal to e to the power something, derivative is e to the power something itself, because the formula for e to the power x function is simply e to the power x. So e to the power, this is considering as x, so e to the power x, into by chain rule you have to take the differentiation of this power only. and the power is a product function actually, cos inverse x into log of sin x. It is a product function. This is u into v format. So first taking the derivative of cos inverse x, that is minus 1 by root over 1 minus x square into this log x, this log sin x is remaining same, plus cos inverse x is remaining same into log sin x derivative is 1 by sin x into sin x derivative is cos x only. Okay, then actually what is the term? This term was nothing but this term, that was nothing but this term, and that is simply sin x to the power cos inverse x. So in place of this one you should write sin x to the power cos inverse x. So dy dx is equal to, this is sin x to the power cos inverse x, and here minus is remaining same, log sin x divided by root over this, plus cos inverse x is same, and cos x by sin x is simply cot x, and that is the solution for the question. And one homework for you, see, this is a homework, y is equal to x to the power sin x. So you may use this method, or you may use the usual method by taking log on both sides. Log of y is equal to, on the right side it will be cos inverse x into log of sin x, then differentiation, then take the cross product of y on the right hand side, then use the value of y is equal to sin x to the power cos inverse x on the right hand side. That will be also give the answer this one. Okay, so you may use the usual method of differentiation of this problem, or this is actually a shorter method than this, shorter method than the usual method, and this question is also is a homework for you. So you can solve this problem by the help of this method, that means the alternative method, or you may use the usual method by taking logarithm on both sides, and it is homework for you. And today we finish the class here, and in the next class we will discuss the rest of the part of this chapter, logarithmic differentiation, and that will be the course for your first internal examination, and after that we will go to the next chapters after the examination. So thank you very much.